And welcome everybody to the Daily Space Weather Show. We've got a geomagnetic storm in progress, some epic coronal mass ejections, and about 169 sunspots. So an uptick, although we'll be having a downtick tomorrow. But yeah, a little uptick in space weather activity here. Exciting times here at the Smash News Network, least busted name in news. These are 24-hour videos from the closest star, taken by SDO, the Solar Dynamics Observatory. And that's pretty sweet, right? That's just happening in the past several hours. That took a long time. And some plasma still likely moving around up there. I'm looking at the GOES 16 feed right now. These are 24-hour videos, by the way, so you'll see that right at the end right there. Major Hyder flares kicking up there as plasma splashes back down toward the chromosphere, and some of that probably did indeed eject. We'll show you coronagraphs a little bit later on. Here we've added 193 angstroms for a little additional contrast there. That's the 60-minute running difference. Here's the full disk view. There's also a CME event happening down in the southwestern limb, which would be your lower right. Here's just 304 angstroms by itself. The ionized helium wavelength from Solar Dynamics Observatory. Yowzers, that is a big filament moving around. Just kind of coming out of nowhere. And of course, sometimes these features are obscured by active regions, as you can see in the 171 angstroms, which especially depicts the lower corona. It's actually probably hiding a portion of that filament there. It's sort of behind all of those magnetic arcs. Very nice imagery. And here's 193 also. Filaments are unstable, and then whoosh. You can see them getting less and less stable, and then the dam breaks. So we'll show some CMEs here in a bit. First we'll cut to sunspots. Yeah, sunspots. We've got, there we go. And that's what about 169 sunspots looks like. Now we'll probably see a slight downtick tomorrow as we've got more setting groups in the west than we have rising or forming. We do have a little bit of growth in the north central region there, but for the most part those sunspots are fairly stable. And let's take a look at what's going on Earth. A surreal scene continues in Iceland. A surreal scene there near the town of Grindavik. And the estimates were that about as much lava has been produced during these eruptions as during the Fagradalsfjall eruption. So there was a flyover, and check it out. There you go. There's what the cinder cones look like from above. There's what they look like right now. A proper Icelandic hellscape going on there. Nighttime in Iceland, illuminated by magma becoming lava. Not half bad. As far as what else is erupting, Bagana now back on the list. Ibu, Semeru, Merapi, Popocatépetl, Santiaguido, Fuego, Revenador, Sabancaya. Next, earthquakes. I could have sworn I had that centered. There we go. There are the past 90 days, and the 7 magnitude earthquake drought continues, folks. 7 magnitude earthquake drought. If you're in an earthquake-prone zone, you may want to be aware of that. 7 magnitude earthquake drought. What do those end in, folks? Let us know in the comments. And of course, here are the quakes that have been erupting. We've got quite a few on the eastern Pacific plate boundary there. Japan also had a 5.2. Indonesia had a 5.1. South Sandwich Islands had a 5.2 there at the Southern Ocean plate boundary. So things pretty calm here for the past 24 hours, the time frame depicted by that USGS. 10.7 centimeter radial flux all the way up to 197 solar flux units, folks. 197 is the new radial flux number, and then when that's updated, it'll be just under 200. You know what numbers are for. That's and next is our Spaceweather Enthusiast dashboard, and it looks like NOAA's now got geomagnetic storm conditions on the forecast right as they arrived. Okay. So it looks like that CME was moving a little bit slower than anybody forecasted. And it's evidenced by the solar wind. So quite a low speed CME currently showing up, creating some geomagnetic unrest. You may have the chance to see the Aurora. We'll show you momentarily on some ways to do that. But check it out. Here's ESA's Enlil spiral, and we'll show more and more parts of the new ESA data portal. So the ESA data portal there providing much higher resolution for their Enlil spirals. Looks like more detail, more resolution, whatever you want to say. So more on the ESA's new data portal coming soon to the channel. It's always exciting to have new data feeds to use, so that's not half bad. Next, Earth's magnetic moment from space for the past 4 hours. And it's been a little bit stormy, but it looks like the conditions are actually waning, folks. So the highest likelihood of viewing the Aurora may have already passed, sadly. It's a pretty weak impact, and it looks like the strongest part may already be behind us. So it was kind of the initial portion of it. Since then, the fields have been weakening. So here's what the ground magnetic perturbations are looking like for North America. That is the past 4 hours. So we may see some mid-latitude aurorae. You never know. It's possible. So it doesn't hurt to check, especially if you've got clear skies where you're located. And it's been quite clear here. Maybe it'll stay that way, and maybe we'll get some aurora to show you on tomorrow's daily space weather video. We're located right about here, by the way, in Lehigh Valley, Pennsylvania. So here's the full globe map, just to show you what's going on there. That is the most likely places to see aurora, telluric currents, pipeline, railway, and power grid induction, where those red locations are there. That is depicting changes to Earth's B field, or geospace delta B, the B field being the field going through the magnet, this magnet being Earth. You can also use the ground magnetic perturbations map. That's showing you induction into the grid. So it's actually empirical data there showing you induction into the power grid. So that can also show you the likelihood of telluric currents happening where you are, and hence aurora above where you are. Of course, you can also use the Space Weather Prediction Center's 30-minute auroral forecast. That's what that looks like. And of course, let us know in the comments if you've used any of these tools to help you see the aurora in your location. And if you've got auroral imagery to share, the best place to do that is on X at x.com/smashomash, otherwise known as Twitter. Twitter.com/smashomash still works also. So there are the auroral ovals. KP5 we had for a little while there. Now it's already dipping down. Again, it's looking like the fields are weakening here, so don't expect too many fireworks here. This wasn't expected to be a major impact anyway. So there's the data from ACE. And it looks like it's ramping down pretty rapidly there. Here's Discover. And the strongest inflection point was right here when we had a 13 nanotesla total field there, that top line, 13 nanotesla total field, and with a negative 12 BZ. That's the vertical component. So that was the trigger for the geomagnetic storm conditions. It wasn't super fast and it wasn't super dense. The density only made it up to about 20 protons per cubic centimeter there. Speed only made it up to 364. Now we are seeing a little bit higher speed trailing portion there, 378 kilometers a second. Could be a co-interactive region, could be a wavy filament too, but in any case, not a major impact. And as you can see, the BZ is headed back toward the 0 line. So we're going to come out of geomagnetic storm conditions quite rapidly if that situation remains. These are our GOES magnetometers, and you can see some sawtooth readings there as the geomagnetic storm conditions showed up. That's no real surprise, right? I'm sure our regular viewers are aware of that. So those are located in the outer portion of the outer Van Allen belt, the GOES 16 and GOES 18 geosynchronous near equatorial satellites. Next is our heliosphere magnetism. Earth is still in a south pole magnetic sector. Nothing to write home about there. Next, solar fields. The polar fields are in south is red and north is green. Solar B field in blue, and then the photosphere magnetism in grayscale there. That's 4 days. That's a lot of information all at once. And here is our coronal hole line of sight plot as we just bring you the most comprehensive daily space weather content and detailed solar imagery in the known universe. So coronal holes, and let's go to coronal holes next from SDO. Do we have coronal holes? No, we don't have SDO coronal holes. Let's get some. So there is our optimal SDO wavelength, 211 angstroms. And you can see that well-defined coronal hole there of south pole orientation here, rotating through the Earth-facing portion of the disk. We can expect that to become geo-effective in about 3 days, so expect an increase in the solar wind density, followed by a decrease in that and an uptick in the solar wind speed. Usually a change in the plasma temperature also arrives with the high-speed portion of the coronal hole high-speed stream. Let's move on to sunspots. Sunspot number 169. 169 sunspots is the new number. And our flare probability monitor and scoreboard is telling us that the likelihood of X-class solar flares is actually very high, especially with that sunspot 3615. 3615 is definitely a major solar flare player. The fields aren't all that complex, but it certainly does have a lot of plasma hanging around it. So there's a lot of potential for Earth-directed CMEs and large solar flares at the moment. Next is our GOES proton flux here, and it's flatlined. We're at baseline levels. As far as the X-ray flux goes, only one minor M-class intensification here in the past 24 hours there, and that's almost exactly 24 hours ago. And let's take a look at our solar system forecast next. That's where things will be in a week. Mercury coming around to meet lonely Earth. Lonely Earth over on this side of the solar system, all by ourselves here with all the other planets besides Mercury on the opposite side. Next, our astronomy photo of the day. And it's a series of galaxies. Not bad. One is edge on. The other two are somewhat oriented toward the disk on the ecliptic plane there. This one is most oriented toward the observer. apod.nasa.gov if you want to check it out yourself. It's the Leo Trio. That's Messier 66, Messier 65, and I don't know. But let's move on to a star chart. So that's what's going on overhead here as the sun begins to set. We've got a rising moon there as well over Lehigh Valley, Pennsylvania. Next, CMEs. Those are important. CMEs, and we've got a couple of them here. That's 86 frames from today. Let's switch to the... There we go. Let's actually... There we are. That's better. All right, so it looks like a CME out of the west according to C3. That's the latest. And then earlier today out of the southeast. And it looks like the most recent one here coming out of the north, so that one's probably not going to be earthly directed. As far as these other ones, let's look a little closer here. We'll look at stereo A also. That's the location of stereo A, by the way. That red dot right there, that's where stereo A is located. And here are its coronagraphs. Well, what do you think? You think they're earthly directed? I'm not so sure, but let's take a little closer look here with our fantastic synced up imagery. So that one that came out of the south may have come from sunspot 3615. So if that's the case, that one could have an earthly directed component. As far as the one out of the west, I don't think it does, but the one out of the southeast may have an earthly directed component. So I would say another CME impact here, likely on the 24th. So March 24th, another coronal mass ejection impact can be expected. So that would be the one right here from the southern portion of sunspot 3615, right there. There was some ejecta there, it looks like. And that looks like part of it is headed Earth's way. Most will miss to the southeast, some likely to strike Earth. And that would be sometime around midday on the 24th. Midday, March 24th, minor CME impact. Don't expect to see much more than a KP4 or 5 from that. These videos come from helioviewer.org, by the way, if you want to get some yourself. Check it out. It's not half bad. Anyway, blasting through the rest of the space weather. Here are filaments, and there are a lot of Earth-facing filaments. Check it out, folks. Lots of dark absorption features there on the solar disk. That's no less than about 8 solar filaments. So pretty serious. Likelihood of additional CMEs and solar flares very high. So it's a space weather watch, and it will continue. So it's another banner moment for space weather as geomagnetic storms roll in. Awesome things happen on the sun, awesome things happen on the channel, awesome things happen in the comments, and with the number of likes. Especially because people like you press the like button. So, thanks to everybody who has. Next bonus features. Satellite charging hazards. We've got some significant charging hazards here over the Middle East and the Far East. Southeast Asia, Central Asia, etc. Charging hazards. Low energy electrons building up on the outside of spacecraft. Electron flux is quite low, as becomes anomalously measured during geomagnetic storms. So it does tell us that it's anomalously reading, typically, and it's actually not as low as it often becomes during extended geomagnetic storms. So there is our 1-year chart and electron flux here just up off the floor from yesterday's reading. NOAA's forecast model expected it to be lower. I think that's going to be pretty much a little bit the same, a little bit higher actually, I think will be the next update there for NOAA. The green boxes are the forecast, the yellow diamonds are the observation. Next is our ionosphere map. This is our ionosonde for the F layer. This layer right here, located at 300 kilometers of altitude. So we're expecting to see quite a bit of low frequency showing up on here toward the end, obviously. But not so much. Just a little bit there. So just a barely even a twinge of a geomagnetic storm there, folks. It's already subsiding, it looks like. So, but if you think you may be able to see the aurora where you're located, make sure you go out and take some photos and videos of it. Remember, folks, most of the aurora is in the ultraviolet spectrum, which is not visible to the naked eye. So if you think you see the aurora, definitely get out the cameras, get the settings set up right and so forth, because then you'll really be able to see them. Your camera is able to pick up a lot more spectra than your eye. Also, it even picks up in the infrared spectra, for example. Again, the aurora are largely in the ultraviolet spectrum. Anyway, here's what's going on in the ionosphere, total electron content, and maximum usable frequency. And let's close out space weather with the latest. Come on, then. There we are. So check out the magnetic complexity of sunspot 3615. It does have some deltas there. It's a beta gamma delta class sunspot. That group there is showing some volatility as well. Some magnetic shear happening in that sunspot, which is much more simple, but still capable of producing large flares, and we could see even a large flare down here in the southwest. So high flare potential, high coronal mass ejection potential. And let's get to weather. So here's our Earth weather portion, and we're showing the stormiest seas in the world. Those are 34.7 foot waves there, and surface winds in the western Pacific. So that's the stormiest place to be on the high seas, folks. And these are your wind patterns. Surface winds, jet streams, surface winds. Once again, surface, 250 hectopascals. Doubled up jet streams over North America. Satellite imagery's next. Some funky cloud patterns there over Brazil. Not caused by HAARP or chemtrails or any other imaginary thing that has nothing to do with weather modification. Some heavy clouds over the Gulf of Mexico. And check it out, windy.com's got a great map of currents. I just figured I'd show that real quick. Currents there, one of the many features of windy.com. And of course the North Sea is like a giant gyre, just rotating there like a giant low pressure zone. Let's briefly take a look at snow, since we want to know what kind of melt season we're going to have. And as far as the water-snow equivalent, the snow-water equivalent, there's a lot of snow right now. So the snow-water equivalent very high, should be a pretty epic melt season. As far as the snow extent, very low there. About 1 standard deviation below the 1998 to 2011 average. And as far as snow mass balance, also kind of low, 1 standard deviation above the 1982 to 2012 average. Weather.gov is next. That is our U.S. weather watches. If your location's lit, click your location at weather.gov. Here's a forecast, GFS 72-hour pressure and precipitation. Very heavy storm is about to erupt in the Gulf. Fortunately, not going to make landfall. Next is snow, and Montana's going to get blanketed almost in its entirety there. That's accumulated positive snow depth change in inches. Here's our total accumulated precipitation in inches. And here is our GFS 72-hour temperature anomaly forecast in degrees Celsius. So a brief warm-up and then cold times returning to the eastern part of the country. That's what's been going on with lightning. Some heavy lightning, like I said, in the Gulf. Some heavy clouds and heavy lightning. At the moment, there are indeed some strikes happening. Also in Texas. Next time you hear thunder, I highly recommend lightlymaps.org. And I highly recommend that you press the like button. Thanks to all of our subscribers. Congratulations on realizing the channel exists. It's only the world's most comprehensive daily space weather content and most detailed solar imagery. No big deal. I can't imagine why there'd be a market for that in today's situation. But here we are. Please perpetuate the channel's existence by pressing like, and if you're new to the channel, press subscribe. We may even keep it in existence. I might even make a video like this tomorrow, as I have for nearly 6 years, every day. Anyway, here is our Doppler radar map, and that's where precipitation's been happening. It shows vertical motion in the air column. Here's our satellite map. It shows a visible series of images. And it is a digital camera, so I mean, I guess it's CGI, if you'd like to argue that it's CGI. This is also CGI because this is infrared spectra, not visible to the naked eye. 6.61 micrometers to be exact. It shows water vapor. So big pressure gradient there happening in the Gulf, where that warm, moist air is unable to support that dry, massive air rolling in from Mexico. Hence, you're getting a lot of vertical motion in the air column. Here's your recap. Doppler radars first, then satellite, and then water vapor. When your Doppler's unclear, consult the water vapor map. And I'm out of here, but I'll see you next time. And in the meantime, may that solar wind be at your back.